Hello students, in the last video we were discussing about strain. So we told there are three types of stress, there are three types of strain, and in that video I told about Hooke's law. It states stress directly proportional to strain, stress by strain is equal to constant, which is modulus of elasticity. So we are going to see different types of modulus of elasticity. There are three types of stress, there are three types of strain. So obviously there will be three types of modulus of elasticity. So let us see that. So the three modulus of elasticity means it is defined as the ratio of the stress to the corresponding strain. Types of modulus of elasticity. So there are three types. The first one is called Young's modulus, the second one is called bulk modulus, and third one is called rigidity modulus. Young's modulus, bulk modulus, and rigidity modulus, which is also called shear modulus. The shear modulus is included, it is excluded from this present syllabus, but still I am teaching shear modulus also. Since we studied three types of stress and three types of strain, we need to study shear modulus also. It is just a matter of one statement. So let us see what is Young's modulus. Young's modulus is found by a scientist named Young. It is the ratio of longitudinal stress to the longitudinal strain. So Young's modulus means it is longitudinal stress to the longitudinal strain. Young's modulus is denoted by the letter Y. So I wrote Y is equal to longitudinal stress by longitudinal strain. And listen here, I can denote longitudinal stress as sigma and longitudinal strain as a letter called epsilon. So sigma by epsilon. If you want, you use this representation, otherwise you can just omit it. Since it is written in different textbook, I have just put that also for your information. Longitudinal stress is sigma, longitudinal strain is written as epsilon. Both of them are Greek letters. So what is stress? F by A, right? Therefore I wrote F by A divided by what is longitudinal strain? Delta L by L. So I have written F by A divided by delta L by L. So this L will go in the numerator. So I will get the equation as Y is equal to F into L divided by A into delta L. F into L divided by A into delta L. Suppose a wire is hang from a rigid support and I have put a mass, so that due to the weight of that mass hanged, the wire is extending downwards. So the cause for the extension of wire is the mass that I have hanged there. Therefore I can write Y is equal to F into L, right? This F is the weight of the wire, at weight of the mass hanged at that time. So I will be putting mg into L by area. Area means area of cross section of the cylindrical wire. For cylinder, area of cross section is circle. So instead of area, I will write pi r square. So I can write the equation as mg L by pi r square delta L. So this also please keep in mind. So the main equation for longitudinal stress is F by A into delta L by L. But if the wire is hanged down and a mass is suspended, and due to the mass, if the length of the wire is increased, then I use the equation Y is equal to mg L by pi r square delta L. So please keep in mind both the equations. If Young's modulus is more, then to produce a small change in length, more force is required. That is understood, right? If I take a rubber band, or if I take a plastic rope and then hang a mass, I need to hang only very less mass, this wire will be extended. But imagine if I am taking a steel wire and then hanging a mass instead of plastic wire, I have to hang more mass, only then the steel wire can be stretched. So I can say Young's modulus of steel is more than that of plastic, or I can say Young's modulus of steel is more than that of rubber. That is why we are using steel to make spring. So they can ask a question, why we are using steel to make spring and not rubber? Because Young's modulus of steel is greater than that of rubber. If I take copper and steel, then which is having greater Young's modulus? Again, the rank goes to steel. Steel is having more Young's modulus than copper. That is why for all the strength purposes, that means all the purpose to make a spring or to hang the load, anything, we are using steel wires. To make the building, to make the bridges, we are using steel wires, because steel wire is having more Young's modulus. So it can withstand with more amount of stress without getting deformed. So we will say like this, steel is having more tensile strength. Steel is having more tensile strength. So that is why the bridges are considered to, bridges are made by using steel and not by using copper. Understood? So all the industrial construction, steel is preferred over copper, because steel is more elastic than copper. If there is a slight deformation in steel due to the contraction and expansion, even if there is a slight deformation, then steel will come back to the original position. That is why if you have walked along the bridges, you can see like that, you will feel like that. When heavy vehicles are moving along the bridges, the bridge will shake, the bridge will vibrate, and you can feel the vibration if you are standing on the bridge. But nothing will happen to the bridge. The bridge is going down, bridge is coming up. That is called vibration. Since the steel is more elastic, it will just vibrate, but it will come back to the original position itself. Okay, so that is the practical application. So SI unit is Newton per meter square or Pascal itself, because modulus is stress by strain. Strain is having no unit. So modulus of elasticity will be having same unit as that of the stress. That is why it is Newton per meter square or Pascal. Metals have comparatively greater Young's modulus. So to change the length of metals, greater force is required. So we have already discussed that. So you just copy these notes. You have to copy the practical application also. What is meant by bulk modulus? It is the ratio of hydraulic stress to the corresponding hydraulic strain. When we apply a hydraulic stress, I told there is a change in the volume of the body, and change in volume to the original volume is called hydraulic strain. And for the hydraulic stress, I am applying normal force per unit area. Think, when we were discussing about stress, I was just showing a ball which is squeezed by the water from all sides, and I told that water is applying pressure, normal force per unit area, that is called pressure. So hydraulic stress means pressure, hydraulic strain means delta V by V. Therefore hydraulic stress by hydraulic strain, P divided by delta V by V. So I can write like this. I can write like this: bulk modulus is equal to minus P divided by delta V by V, that V will go top. So, PV by delta V. Bulk modulus is equal to minus PV by delta V. Why I am putting a negative sign? Because when the pressure is applied, volume is decreasing. So, to show the decrease in volume, I have put a negative sign. Okay. So, P is the hydraulic stress, which is same as pressure, delta V by V is the hydraulic strain. Negative sign shows that increase in pressure results in decrease in volume. Again you can see SI unit is Newton per meter square or Pascal, that means same as that of stress. Bulk modulus of solids is very much greater than the liquids, and then bulk modulus of gases are small. So, gases have very small bulk modulus, okay, and bulk modulus is more for solids, because solids are least compressive, that is why. What is meant by compressibility? I just now used the word solids are least compressive, right. So, what is meant by compressibility? Compressibility is the measure of the compression of a substance, and it is termed as reciprocal of the bulk modulus. So, compressibility means reciprocal of the bulk modulus. So, I will write compressibility as small letter k, that is 1 by B. So, our equation for B, just remember in the previous slide, I gave equation for B as B is equal to minus P V by delta V. So, compressibility K is equal to 1 by B, which is delta V minus delta V by PV. So, compressibility of solid is least, liquid is greater than that of solids, and gases are highly compressible. Which is having more bulk modulus, water or air? So, you can think like this, air is more compressible than water, right. So, bulk modulus of air is more, bulk modulus of air is less. Okay, compressibility is the reciprocal of the bulk modulus. So, compressibility is more for gas, bulk modulus is lesser for gas. So, air is having least bulk modulus. So, air is highly compressible, least bulk modulus. So, we can say water is more elastic than air. Okay. If they ask you a question which is more elastic, water or air, water is more elastic than air, because bulk modulus of water is greater than that of air. Now comes the third thing, shear modulus. Shear modulus is defined as shearing stress by shearing strain, ratio of the shearing stress by shearing strain. It is denoted by G. Again, as I told, unit is Newton per meter square or Pascal. So, I just wrote G is equal to shearing stress by shearing strain. And what is shearing stress? F by A. Shearing strain we studied in the previous video, delta x by L. I told you either you can write x by L or you can write delta x by L. So, shearing strain is delta x by L. So, FL by A delta x, that is shearing strain, or delta x by L is called tan theta. You just view the video strain. There, when I was explaining shearing strain, I told shearing strain is tan theta. So, this is tan theta or this is theta. Therefore, I will write F by A theta also. So, this is the equation for the shearing strain. Okay. Relation between Young's modulus and shear modulus. Shear modulus is always lesser than the Young's modulus. So, for most of the materials, G will be equal to Y by 3. G is lesser than Y. That is why you think taking a paper. If I take a paper, we can easily fold the paper, turn the paper, twist the paper, that is easier. But in order to stretch the paper, we have to apply more force, because you can twist, you can turn, all those things comes under rigidity, shearing. So, shearing is less, shearing stress is less, rigidity modulus of elasticity is less. That is why it is easier to slide the layer of atoms of solids over one another than to pull them apart or to squeeze them closer together. That is why I say we can twist the paper or fold the paper easily, but you have to apply more force to stretch the paper. Now, what is called elastic after effect? Elastic after effect means it is the delay in regaining the original stage of a body after the removal of deforming force. If I take a spring and compress the spring, then release my hand, it will come back to original shape all of a sudden. So, its elastic after effect is less. But you take glass fiber and bend the glass fiber, it will come back to the original position, but very slowly, it will come back to the, I am not talking about the glass, I am talking about glass fibers. When you bend the fiber, it will come back to the original position, but it will take a lot of time, it will come very slowly. So, elastic after effect is more in that case. Now, what is meant by elastic fatigue? Elastic fatigue is defined as the loss in the strength of a material due to the repeated alternating strains to which the material is subjected. That means, if I bend the wire to and fro continuously, upward and downward, to and fro continuously, the wire will break after some time, because we can say the wire has lost its elastic strength, or wire has become elastic fatigue. Due to the same reason, railway bridges are declared unsafe after a reasonable good period of time to avoid the risk of mishap, because the train is continuously moving along the rails. So, the rail will go up and down, up and down. It is slow, it is very small, but since the rail is vibrating, continuously it keeps on vibrating many times, then what happens? It will reach elastic fatigue, it will lose the property of elasticity. That is why we have to replace that rails. If the bridges, we are using bridges, so when we use bridges, after some 50 years or 75 years, we have to make new bridge. Old bridges are unsafe because it will reach elastic fatigue. So, that is all for today. Thank you.